This video is about solving quadratic equations, and we're going to look at 3 different ways of doing that. First method that we'll introduce is isolating a variable. This is useful when a variable appears only once in an equation. So for example, in this first problem, x only appears in this position here inside of the square. And so the strategy of isolating the variable is to move things to the other side of the equation until x is by itself. So we look at the formula, and the side with the x, the last operation of this side is adding 2, and so we will progressively use inverse operations to move things to the other side. So we will start by subtracting 2. Once we subtract 2 and have 5 on the right hand side now, the last operation on the left, what do we have? We have multiply by 3 and a power. So powers occur before multiplication in the order of operations. So times 3 is the last operation. Its inverse step is to divide by 3. Now, the last operation on this side with our variable is the squaring. So our inverse operation would be to take the square root of both sides. Alright, now square rooting a square, it's like they cancel, but there's one thing that happened. When I squared my number, x minus 2, and I squared it, I lost track of whether x is above or below the 2, whether that difference is positive or negative. So when I use that inverse step and get rid of the square root of a square, I introduce two possibilities. My x minus 2 might have been plus the square root of 5/3, but it might have also been minus square root of 5/3. And this is a common mistake that students forget when they do a square root of a square. There are actually two possibilities. It might be equal to the positive root or the negative root. And now I finish. The last operation I need to move is I need to add 2 to both sides of the equation. So x has two possibilities. It might be add 2 plus square root of 5/3, or x might equal 2 plus a negative square root of 5/3. And those are my two solutions. The other two methods that we'll talk about for solving quadratic equations both involve rewriting the equations so that we have a formula equals 0. And we have these two strategies. One is to factor, and our goal there is to try to rewrite it so that we have a product of two things equals 0. And if we don't want to do that, or if we can't do that, our third option is to just identify the coefficients and use the quadratic equation. So I have an equation 2x squared minus 3x equals 20, and I want to try to use one or both of these methods. I will actually do both. And so the first one, we are going to start by trying the strategy of factoring. In both cases, we need to rewrite our equations so that we're equal 0. So I will move, I need to get this 20 out of the right-hand side of the equation. We'll subtract 20 from both sides, and we get 2x squared minus 3x minus 20 equals 0, and we can try to proceed. Alright, even though we're not using the quadratic formula, it's helpful to recognize what our coefficients are. So a equals 2, that's the coefficient of x squared. B equals negative 3, that's the coefficient of x. And c equals negative 20, that's the coefficient that doesn't have any x's. When I want to factor it, if I can't see directly how to factor, what I'll do is I'll take the product of a times c. So here, a times c equals negative 40. And we're going to look for factors that add to give me the value of b. So the factors that sum to b, which is negative 3. Okay. So I think about negative 40, and with a little bit of trial and error, I realize that 8 and 5 are factors of 40. So I'm going to write this as 5 plus negative 8 give me that value of negative 3. My strategy for factoring is I'm going to rewrite the middle term, the minus 3x, so that I get 2x squared plus 5x plus negative 8x minus 20, or plus negative 20. And we're going to group our terms. Now, once they're grouped, we're going to look for common factors, and so the first one has a common factor of x, so I get x times 2x plus 5. And the second term, I always want to bring out a negative if there is one, so it is actually negative 4 is a common factor. So I have negative 4 times 2x plus 5. Now, because of how we constructed our factors of negative 40, I always will have, if it factors this way, my second factor will always be a common factor. So that I can now factor that out. 2x plus 5 times x minus 4 equals 0. And I'm now in the form of a times b equals 0. Now the reason that I use factoring is if I can multiply a times b equals 0, one of my two factors have to be equal to 0. So I have two possibilities. Either 2x plus 5 equals 0, or x minus 4 equals 0. And now these aren't quadratic. I can just isolate the variable x. For the first equation, I'll subtract 5 and divide by 2, and I get x equals negative 5 halves. And the second one, I get x equals 4. And those are the solutions to my quadratic equation by factoring. Now we're going to solve the same equation using the quadratic formula. And the quadratic formula requires the same setup. So we are going to first get the equation so that it's equal to 0. That's my new equation. And again, we're going to identify my coefficients of x squared, of x, and of constants. And the quadratic formula is a rule that when I know a, b, and c, the coefficients of my quadratic, it tells me what my solutions are. And I like to sing it to remind me of the parts. So x equals negative b, let's write this down, negative b plus or minus the square root of b squared minus 4ac all over 2a. And I find the equation solution by substituting in my values. I get x equals negative b, negative of negative 3, plus or minus the square root of negative 3 squared. And I suggest you do use parentheses around that negative 3, especially if you use a calculator. If you wrote negative 3 squared, it'll actually square the 3, not the negative 3. So minus 4 times a times c. And then all over 2a, 2 times 2. Right, well those are the solutions, but it's not simplified. So let's see what happens. I get my x equals negative of negative 3 is plus 3. When I multiply these together, I will have, let's see, 169. So I need the square root of 169 and then divide by 4. Square root of 169 is 13, so I get 3 plus or minus 13 divided by 4. And I need to finish by separating those and treating them separately. So one solution is 3 plus 13, and then divide by 4, which is 16 fourths, or 4. And the second is 3 minus 13 divided by 4. That's negative 10 over 4, or negative 5 over 2. And so I get, should not be a surprise, the same solutions we found by factoring.